everyone to our privacy on Pantheon sort of webinar. And just as we're getting started, I have in my head that I need to remind Grace to hit the record button. So I'm going to ask Grace to hit the record button. I'm seeing a thumbs up that she's hit the record button. So thank you, Grace. So we're looking at today in this in the PegaSys webinar series, looking at privacy in Pantheon, and a glamorous sounding title of how PegaSys has redefined blockchain for enterprises. And whether or not it's a full redefinition or if it's a evolution of the things that are happening, we'll see as we go. But I am actually, with full integrity, really excited about the things that we get to talk about today, both where we are now and where we're going. So as we step in, let me do a little bit of an introduction. So my name's Rob Dawson, and I'm the product lead for the PegaSys team. And we have Anthony Denya on the call as well. So Anthony, would you introduce yourself?
Hi, my name is Anthony Denya. I'm CTO of Web3 Labs. We're primarily known for a product called Web3J, which is the main Ethereum client library. We're also heavily involved with the Enterprise Ethereum Alliance, specifically around privacy and the client specification. I'm super excited to be involved with this collaboration.
And the reason that we particularly have Anthony from Web3 Labs involved is they've been very, very heavily involved with the implementation of the work that we've been talking about, and actually all aspects of this solution. So we're going to be talking through why privacy for blockchain for enterprises, why it matters, looking at how some of the off-chain transactions work, looking at how different blockchains treat privacy, talking specifically about privacy in Pantheon and some of the details of that, and looking at some of the bigger picture, where we are now and where we're going with our privacy work with Pantheon. So just a few friendly reminders as we kick into the actual meat of things. So first, please mute. It looks like everyone's done a great job of that, and thank you for that. Please do also go ahead and ask questions in the chat. We'll pause at various points throughout this webinar to give opportunities for people to ask questions. Someone will be reading out the questions from the chat. We'll definitely give you every opportunity to ask your questions. And then at the end, we'll also have a final kind of wrap-up Q&A section. We are recording this session, and so it'll be available for people to watch in the future and for you to share with colleagues and other people. And also we'll be sending recordings and materials, including a blog on privacy that we've just posted in an email after this session. And finally, with these sort of friendly reminders, I'll remind you again at the end, but we'd love your feedback. And so we want to make sure that we're improving these webinars, delivering good value. So there'll be a feedback form with a link that's included in the email information as well. So let's get started. PegaSys' mission is to make Ethereum enterprise ready. And so it's big sounding words. Let's just drill into that a little bit. And so there's a few big aspects of this. So the first is making sure that mainnet is awesome. And so we think in the fullness of time, mainnet is where all the action is. And so we think that there's a bunch of things that consortiums will do that add value outside of a mainnet, but that there'll be pinning of information back to mainnet, and everything will sort of work together in a mainnet world. So we want to make sure that mainnet works really well, and we've got a research team and developers working on both the Ethereum now and the Serenity, the future versions of Ethereum as well. We think that enterprises have a specific set of needs and requirements as well. So they want a really high quality client that they can trust, that works on a technology stack that they know and are familiar with. And so we've done that with producing our Apache 2 licensed Java client. We also think, though, that there's some specific features that are important for enterprises, of which privacy is one of those. And that's why I hope you're all here today to hear me talk and Anthony to do a demo about our privacy work. So lots of different blockchains treat privacy differently. There's many of these things will sort of be familiar, and you'll see some of the logos here. There's private channels, there's point-to-point privacy, multi-party computation, zero-knowledge proofs. Our new thing that we're introducing is privacy groups. Each different organization has, and each different chain that talks about doing things with enterprise has its own different way of wanting to do things. Today, we're going to be looking at what Pantheon does and focusing very much on our solution. But before we get to that, let's just talk briefly about why. And so, clearly within an enterprise, you've got information that is important to get pinned to the blockchain and get communicated out that, hey, we are committed to this being available for everyone to see that we've got this information that's available without actually revealing the details of it. And there's two different ways really for that to happen. It's sort of, of the myriad of different ways, it sort of narrows down to two sort of main different approaches. So one is to do something that's on-chain. With an on-chain solution, you have some sort of cryptographic technique. You can sort of see the row of nodes that we've got sitting up there with our chain at the top, where there's some data that's sitting there that our transaction is encrypted. The parties that are involved with the transaction are able to access that encrypted transaction. Those that aren't able to access it. And so whether that's the full transaction or some part of it that's encrypted with some sort of zero knowledge technique, that's kind of the general thing that we've got happening with an on-chain based solution. With an off-chain solution, what you'll do is you'll have some sort of marker of the transaction written to the chain, so some sort of hash, but the transaction itself is only distributed to the parties that are involved. And so they will look up that transaction with some sort of marker that's written to the chain that everyone can see, but the actual transaction payload is only shared with the parties that are involved. And that's often used for situations where you actually, for regulation reasons, you do not want to have the details of the transaction shared, even encrypted on a blockchain environment. So we're going to be talking a lot about off-chain transactions. That's the focus of the privacy solution that we're talking about today. So how do they work? And so here we've got a sort of visualization of it. We've got two different privacy groups sitting in this system. So we can see that the green kind of privacy group with 3 nodes down the bottom would share some state, share some transactions that are only distributed to those 3 nodes. The 2 nodes at the top, the blue nodes, would have a different privacy group and be sharing some different state. So in Pantheon, when we talk about this is what we're using. We're using these privacy groups to keep the state in sync within that privacy group, but separate from the members that aren't a part of that privacy group. While doing that, having some sort of hash of the transactions that make up that privacy state that's written to the main chain, so that people are able to get confidence that, hey, there are transactions that are happening. If there is a case where the parties involved in the private transaction need to prove that it's happened, they can point out to this is the transaction that's from that hash. This is what's built up our state. So one of the key things that we've got with this privacy groups is that the state within that privacy group is kept in sync with the parties that are involved in the privacy group. And so that helps give some confidence that what you're seeing within your privacy group is the same as the other members of the privacy group. So we have this backed within Pantheon by a private transaction manager, Orion. And so within our system, when we were talking before about the 2 different privacy groups and that the information be sent to the members of the privacy group, it's through Orion that the transactions are transmitted. And so Orion's job in this scenario is to be transmitting the private transactions to the nodes that are involved. And so in the situation where there's a privacy group involving Alice and Bob, in this case, Alice would be using Alice's Orion to send the private transaction to Bob's Orion. And that's how you'd end up in that spot where the private transaction is only available to Alice and Bob in that privacy group. And Charles would not have that message being sent to his Orion. So going through this one more time, and I'm going to just pause at the end of this walkthrough and give a quick chance for questions, and then Anthony is going to dive in and do a demo. So if we look at this, yep.
Rob, sorry, this is Grace. We have a bunch of questions, so I think maybe before we go into the demo, let's go ahead and answer or go into this kind of diagram and discussing this. Let's answer a couple of those. Does that work?
Sure, sounds great.
Because everyone had some good ones. So let's start with the first one, I think from Simone. What prevents a privacy group made up of 2 nodes not to collude in updating the private state and double spend their funds?
Yep, so the funds for that case in that privacy group would only be available to the members of that privacy group, and the shared state would be only available to those members. So if they want to collude between themselves and do things strange between themselves, that's up to them. But what the key thing is when you've got a privacy group with 3 members, all 3 members will have their state kept up to date and in sync with each other. And that's the key thing that the privacy group is preventing.
And the follow-up question is from Simone, I believe, is it similar to Quorum?
So the solution is very similar to Quorum. I'll dive into where some of those key differences are, which I called out on this slide here, actually.
Yep. And then Marty, it seems, has a very similar question. So your question's going to be answered coming up real fast. And then I think Ken just made a comment about the illustrations, which is great. And then the last one was Constantine. Is there a lag time between the actual private transactions and publishing the hash?
Yep. Okay. So let me do the full set of things with this one, and hopefully this should answer those questions. So looking at this is kind of the big picture of how everything hangs together. So you can see that there's a DApp there that's submitting a private transaction to the network. It flows through the JSON RPC to the private transaction handler. And so overall, this is a very similar approach to Quorum. So flowing through this sort of approach, you can see that the private transaction handler will receive the transaction. It'll give it to Orion. Orion will then pass it off to, or look at the transaction, identify the recipients for the private transaction, and pass that off to the remote Orions. Before passing it off, it will derive the privacy group from the list of members. And so that privacy group is something that Quorum does not have. And that's one of the key differences between the solution here and the Quorum world. So the privacy group is what sort of helps you ensure that the transactions then moving forward are made available to all members of that privacy group. And the transactions are stored against the privacy group. So you can see as the transaction moves through to the system, moves through our privacy precompile into the private transaction processor, when it executes the transaction, it then executes it using that privacy group to have the state for it, and we end up with a separate state for each privacy group. So with that happening there, the other thing that we see as a key difference is that the way that the transaction processor implements things and works and marks the private transaction is by issuing the transaction against a precompiled smart contract. And by using a precompiled smart contract, we are keeping this solution in track with a standard Ethereum, and it keeps the way that privacy precompile working is making sure that what we've got here is a Ethereum compliant sort of solution. It's I guess a point of difference with Quorum, where it will write a transaction hash as a special transaction against the ledger. And so rather than using that special transaction that's not standard, not quite a normal Ethereum transaction, so it has a way of marking that with a change to the transaction signature, we actually are moving this forward in a way that makes it more of a standard Ethereum transaction by sending the marker as a standard Ethereum transaction to a precompiled smart contract. And then the precompiled smart contract will be responsible for retrieving that private transaction from Orion and storing it and executing it against the world state. So it's a huge amount of detail that I've gone through there. Don't feel at all bad if I've overwhelmed with detail. Anthony is going to go through and do our demo. I'll give another chance for, it's probably, I think, worth rolling onto the demo now. And then we will come back to this slide again and get a really good chance for some more questions.
Cool, thanks, Rob. Can we just flick back to the Alice and Bob example on the slides?
So here, or the...
There we go. So
how far back do you want to go?
Yeah, that one. So in our demo, what we're going to do is set up a transaction between Alice and Bob, and Charlie's not going to be able to see the transaction. So it's going to be a very simple demo with a simple privacy group between Alice and Bob, and Charlie's going to be excluded from that transaction. So what I'm going to do now is go ahead and share my screen, if I can. Rob, can you relinquish?
Hey, Rob, have you stopped sharing?
Thank you very much. So you should be able to see my screen now. So all I've done is I've cloned down the quick start. Let me just scroll back to where I am. I've cloned down the Pantheon quick start example. I've seeded into the privacy directory, and I've called run. Now what this has done for us is it's spun up 3 private nodes and 1 miner node. So we've got 1 miner node running and 3 private nodes. Each private node has got RPC enabled and exposed, all on a different port, so we can communicate directly with each individual node. What we're going to do is we're going to deploy a very simple event emitter. All this does is it stores a message, or stores a number in this case, and emits an event once it's stored. So super simple, super simple. To deploy the contract, what we're going to do is we're going to deploy it from node 1, or Alice in our case. We're going to take the events emitter binary, and we're going to take the private from, so from Alice, we're going to make it available for Bob, so node 2. We're going to specify a private key here because we're signing the transaction locally, so we're specifying our Pantheon node private key. One thing I forgot to mention also is we're specifying our Orion public keys here. So it's the public key from Alice and the public key for Bob. So if you're familiar with Quorum, this is almost, well, it is basically identical to the way they've implemented in Quorum with the send raw transaction. So once we've got all those contract options set up, we're going to go ahead and call EEA send raw transaction. This is a RPC endpoint that we've implemented on Pantheon. And essentially what that's going to do is when the transaction is submitted, what we'll do is we'll propagate the private part of that transaction to our 2 Orion nodes. Once it's finished propagating to our 2 Orion nodes, we'll go ahead and the transaction will be submitted to the blockchain. So it's almost like a 2-step process. So you get the private part done first, and then the public part done afterwards. But obviously from the RPC endpoint point of view, it's 1 single transaction. So I'm going to go ahead and call that. Where are we? One place. So we deployed the contracts. We've got our contract address being generated, and we've got our usual sort of output that we would see. So now what I'm going to do is I'm going to store a value from node 1. So this is Alice setting a value on that node. So you'll notice as well, sorry, one thing I forgot to mention on my deploy, where we're deploying to node 1. So again, on this one, we're talking to the RPC endpoint on node 1, specifying the contract address we're interested in. So again, because we're doing a raw transaction, we need to go ahead and basically sign this ourselves. So the parameters for this again is going to be from Alice. So it's from Alice's public key. It's for Bob's public key. And again, because we're signing it locally, we need to specify our own Pantheon node private key. One thing that we're working on at the moment is transaction manager. So in the sense, so again, if you're familiar with Quorum, you'll automatically take care of the nonce for you. We haven't got around to implementing that at the moment, so you need to manually specify the nonce of your from address. So in this case, obviously, we've just deployed the contract at 0, and we're doing another transaction after that, so the nonce is 1. Once we've done that, what we're going to do is we're going to check that we emit the event, have a look at the result of the transaction, and then we're going to call get value 3 times, once from each node, just to demonstrate the different values that each participant in our enclave consortium can see. So I'm going to go ahead and call our example. So what we've got here is the public transaction hash of the market transaction. So this is what you would see on your blockchain. We've got the event that's emitted, so we can see that we've emitted 1,000 in hex. And then what we've done is we've made another transaction call from node 1 to go and get the value. And you can see that node 1 thinks that the value is 1,000 as well. We've done the same against node 2. And you can see that node 2 thinks that the value is 1,000. And then we've done the same transaction again from node 3, but we just get nothing. So node 3 cannot see the transaction, or cannot see the private data. So again, what we're going to do is exactly the same thing against node 2. Again, our nonce goes up by 1. This time we're going to be specifying the private from as node 2, or Bob, as we like to think of him. And then its private for is it's private for Alice. So it's node 1. Talking back about privacy groups. So the privacy group is derived from the participants in the transaction. So this is basically the thing that's going to tie together these 2 transactions. So you've got the privacy group 1 and 2, and we've got privacy group 2 and 1, and therefore it derives the same privacy group. This time I'm going to set the value to 42, and let's go ahead and run that. So again, we've got our, just wait a second. Again, we've got our public transaction hash. So this is the transaction hash of our market transaction. And the event that's emitted on the transaction is 2A or 42. And again, get value from node 1 is 42. Get value from node 2 is 42. And get value from node 3 is undefined or not known. I think that's about everything from the demo. You got any questions at all about the demo, Grace?
Yeah, it looks like Rob answered one, but Ken asked a question. So where do you see the privacy groups here? Do you specify the list of recipients every time, or you can simply send to a privacy group that includes all the recipients?
Yeah, so at the moment, the privacy group is implicitly calculated on in Pantheon. So it's one of the things we're looking to do in the future in our next release is to be able to specify the privacy group ID on the send raw transaction endpoint. So for instance, here, instead of specifying from and for, you just specify a privacy group. One of the other features we're looking to do in the sort of over the next few months is to enable you to add and remove participants from a privacy group. So that way you can, over time, add more people into that transaction. Obviously, one of the downsides of that is, well, one of the problems of that is you're going to have to have access to all of the information previously in that privacy group. So, there's a cost to it, but I think it's really interesting advancement in the privacy world.
Cool. So Simone also has a question. At what point a transaction executed in a privacy group can it be deemed final? What data is recorded in the public block?
So one of the caveats with our implementation at the moment is that you need to be using a consensus algorithm that supports transaction finality. And essentially that means that we're not ready for mainnet at the moment. So again, one of the features that I think Rob will be talking about shortly is private consensus and some of the interesting things we're going to be doing over the next few releases. So I think Rob will be touching on that in a bit.
Looks like we have well, I'm not going to say his name correctly, so I'll just ask a question. Can you deploy a smart contract to several participants and then not include the same group of participants when transacting with that smart contract?
No. So one of the things we felt about this was that it's basically no. So once you specify the groups in the initial contract deployment, we feel that should stay the same forevermore, and that you shouldn't be able to edit that. And yeah, maybe Rob can touch on it a bit more, but it's basically down to the way we've implemented it. So no is the answer.
So that's a very deliberate. I'll hop in and say there's a very deliberate decision of making sure that the state for the privacy group is kept consistent, and it saves from a whole series of situations where you could deliberately confuse the state between the different participants. And so by doing that, it does mean though that all participants in a privacy group need to see all the transactions. One of the things that we're moving forward with this approach is to add in communication across different privacy groups. And so that in that sort of scenario, you'd be able to specifically send transactions from a smaller subset group. And so you could have two different privacy groups, one with 3, one with subset, and send a message from that smaller subset to the bigger.
So I think that's a great point, Rob, too. I think, so we have a couple more questions. I think they're, or we have actually a bunch more questions. Everyone, you're asking great questions. I think it makes sense to maybe start answering them, starting with the next slide, Rob. Does that sound all right? I don't think anything's demo specific, but then we can start going through each of them. I have been collecting everyone's questions, so we will be answering them. I know they can get lost in the chat.
I'll try and jump on the chat as well and answer a couple of questions as well.
Mm-hmm.
Good. So just running through that diagram again, that familiar diagram. So we've got a few things that I just want to touch on briefly. So the first thing is that we've got a Orion sitting there that derives the privacy group. Within the current version of the system, that privacy group is kept as an internal supporting concept. And so the transactions that are made against contracts within that privacy group are viewable to all members of the privacy group. If you wanted to be doing something that is shielding some of the balances from people, perhaps using another technology like a zero knowledge type solution, would make sense, and that could be layered into the existing system. So if we were to say that that's how we sort of would fit in with the privacy group world there, when the transaction is being written to the main chain for everyone to be able to see, that's a hash of the private transaction that's written to the main chain. And that's the marker for people to know that all the Orion nodes now have the private transaction, and that once that's been executed, the privacy precompile will have executed and updated the state for that privacy group. So what I can do is just pause here and see if there's any other questions that we want to ask right now, and then move on to the next spot where we can do some more details about where the roadmap is going and where we see privacy groups going in the future.
I think it makes sense to take a couple. So I think one good question we had earlier was, what if the private state of one node gets lost? Is there a recoverable mode from other nodes?
So the recovery of that at the moment, there's not a strong recovery mode. Once we add in the support for updating the privacy group membership, that's where there'll be a great way to do that. And so, having said that, the recovery would actually right now be you could reinstall a node that talks to an Orion and has the key that knows about that Orion. And so if you configure the Pantheon node to know an Orion node, when it's syncing up, it would interact with the Orion, it would replay its public state, it would then retrieve the transactions from the Orion node. Yeah.
Next one is membership, I think this was answered earlier, is membership to the privacy groups persisted, and can additional parties be added after the transaction is complete?
Yep, so in the current version, the updating the membership is not supported, but in the roadmap and in a future version, that will be changing.
Okay. Next question, can I be in more than one privacy group? How will my Orion manage that?
Yep, so it definitely can be in multiple privacy groups. Orion will just store the transactions and mark them to be associated with the privacy group, but you can definitely be in multiple privacy groups. And the Pantheon will store separate state for each of those privacy groups and keep those states separate.
Great, and then one more, and then we can keep going, and then we'll have a big Q&A session at the end, so everyone you're asking great questions, keep asking. Can you call public smart contracts from private ones?
Yep, so the private smart contracts are able to read from the public state, and so they're not able to do mutation operations because to do that, you would need to actually make sure you're doing it in a way that creates a transaction for everyone to see on the public state. So that's not supported at this point in time, but right now you can definitely read from the public state from the private state. So I think, as Grace was saying, we might move on to the next slide and talk to the roadmap. And so we've got our 1.1 release that's just been made, where we've got the Orion that we've shown off, the restricted privacy solution that we've shown you. We then have got our 1.2 release that's scheduled for July, the end of July. And so the key things that I want to strongly commit to in that release is supporting privacy groups in the API. And so making it so that you'll be able to send transactions specifically to a private privacy group. You'll be able to look up a privacy group. You'll be able to create a privacy group with a label sort of attached to it. And then you'll be able to look up the list of privacy groups. So very much around that privacy group being exposed in the API is the strong commitment that we've got for July. The other thing that will be there is within Orion, supporting more external key management and supporting HSMs within Orion for the encryption operations that it performs. The next thing that is going to be happening after that is supporting the add and remove of membership to a privacy group. And so I have that there as a thing around that 1.2 version. I expect that the work that's involved in getting a robust solution around adding and removing membership to a privacy group is going to actually roll into the 1.3 release, which would be probably slated for around the DevCon version. And so that would be the sort of October, November kind of timeline. So looking at our roadmap then, the key things that we've got coming up is that privacy groups coming through in the API. So being able to actually just interact with privacy groups. So our reason for not doing that initially is we wanted to make sure that we were compliant with the EEA raw transaction APIs. But as we move forward with that function, we know and are well aware that being able to be able to actually work with these privacy groups, we think that they're a really good concept, and so exposing them out through the client API is going to be a really valuable thing. And then there was a few things that we're sort of touching on as well in the future that we can see sort of rolling forward with the function. So the key with those is, I guess the two big things that we see as really valuable is using, implementing some sort of consensus mechanism on top of the privacy groups. So at the moment, there's a rough consensus that's going to happen based on the fact that the market transaction will not be submitted to the public chain unless the private transactions have all been shared across the network and distributed appropriately. We will be expect to be strengthening that over time with a very strong consensus mechanism across the privacy group. The other thing that we'll be looking at adding is making it so that a privacy group can send messages to another privacy group, and a privacy group can send messages back to the shared ledger as well. And I think with that cross-privacy group communication, we end up with a very, very solid solution that's amazing. So I think we've got a good solution now, but we've got a great solution that's coming forward, particularly when you add in the two big things of the maintaining the membership and being able to do cross-privacy group communication. And once you get to that point, we're actually very close to a sidechain kind of world. And so I think again, just flagging very, very briefly, the key things that we see coming forward are the privacy groups in the API. And so that's definitely in our 1.2 release. Moving forward, the management of that membership as well. And so as we look forward with this solution, I think it's going to be a really, really good sort of privacy group communication. So cross-privacy group communication would be if you've got a privacy group involving members Alice, Bob, and Charles, and they wanted to send a message to a privacy group, and you had another privacy group with Alice and Bob, you might want to send a message from the Alice and Bob privacy group up to the Alice, Bob, and Charles privacy group. And so it's sort of being able to do atomic transactions between the two different privacy groups. And so in terms of a use case, that would be, I guess, potentially, I guess if you're doing a settlement operation, as you're potentially negotiating price between parties, you might say that you want to go from that, create a privacy group with Alice and Bob to do the negotiation around the price. As they come around to a final price, they might push that final sale up onto the to the more public kind of ledger. And so that ends up being the way that sort of would work. The other thing that, another feature that we're looking at to help make this work really well is being able to move the communications from, at the moment, the Orion to Orion communications, moving some of that communication to using the peer-to-peer networking communication in the Pantheon node. I can see a huge stream of questions flying past. I'm going to ask Grace if there's any that she wants to pick out for me to answer.
I can just ask a good one. And on-chain privacy is replacing the communication protocol between Orion instances from, I guess, XXX to encrypted transaction. Right. So
I think the on-chain is, I guess, a part of our overall privacy roadmap is that we think that there's more than one privacy solution that's needed. And so I think that saying that there's one privacy solution to rule them all is not correct. And that having a mix of off-chain privacy and on-chain privacy is the way that we should be thinking about these sort of solutions. No one privacy solution is going to meet all use cases. And so having additional on-chain privacy solutions, I think, to support some of the solutions that make up like an Orion type solution or an off-chain type solution, as well as having the on-chain privacy solutions as well. So more, I guess, zero knowledge and cryptographic techniques for doing some on-chain privacy as well.
Rob, so that it was a good lead up to maybe have one more question. A couple of people have asked, like, what are the use cases for this privacy feature? Someone just asked if we could use privacy feature for consortiums.
Yep, so I'll hop in with the consortium solution. So I think hopefully the use case I gave earlier. So one of them is for actually what I'll call out for use cases. The blog post that we've published has some great blog posts talking about it. And goes into some details talking about some examples. In terms of consortium solutions, definitely, and Pantheon is very much with the privacy feature that we've released here, and with our recent permissioning features that we've been releasing. These both fit in very well to a consortium sort of network.
Okay, I think we can keep going, and we'll answer some more of your questions at the end. I know we're at almost time, but we're willing to stay on for an extra 10, 15 minutes for whoever else would like to join, and we'll continue answering questions. So I think so.
Yep. And let me just answer one question before I hop off. So there's another question I think has been asked a couple of times about the running instances of Orion. And so there's I guess a parallel roadmap that's not included here around doing some improvements to Orion. And so the features that are being slated for that. So right now the answer is yes. Every node needs to have its own Orion that's paired with it. As we move forward, we can see that there's a few things that would set in with that. So first, within our Orion, support for external key management. The second feature is making sure that it works really well for disaster recovery and high availability sort of modes. And the third feature that we can see as very important is being able to decouple the one-to-one relationship between Pantheon and Orion to moving to a spot that has a many-to-many between Pantheon and Orion. And so with that, I'm going to hop across to the next slide and just talk about, again, our bigger picture roadmap for Pantheon. And so there's three things that I guess that we're really working towards. And so the enterprise Ethereum space that we're talking about here. So things like our privacy, the custom consensus mechanisms, side chains, having a really good permissioned system, and making sure that we're compliant with the Enterprise Ethereum Alliance specification. The next direction that we're looking at is the Ethereum 1.x work. So things like the EWAS and precompile, state fees, state pruning, making sure that Ethereum continues to work well. And then our final sort of big direction that we're working on is the Ethereum 2.0 or Serenity roadmap. And so that if you follow that, it talks about three phases, starting with a beacon chain, and moving forward to another couple of phases around the actual transaction sharing and transaction execution. And so we are very active in our phase 0 sort of work. And so we've got a team that's got a project Artemis, which you can see on GitHub, which goes into the details of that. And we'll be actively involved in the other phases as they move forward. And so I'm going to hop across to the last question slide with a reminder for people to fill out the feedback form, which will be emailed to you, and I guess a request to email us. And with that advertisement, I will pause for more questions. And I can see Grace has just put a link to the feedback form in the chat.
All right, so keep going with questions. If I missed your question, feel free to also drop it in the chat again or speak up, but we'll keep going down the line. We had one question: what is the economic model for transaction processing? Who manages the transaction cost burden in this model?
Yep, so for most of the networks that we're seeing in this kind of model, it works with a zero gas setup, and that the transaction costs are managed through the consortium. There's nothing preventing the transaction cost from being using a gas fee system to help, and that would go onto the public side. The nodes that are executing the market transaction would be then sharing the gas price for that, and would help with that.
Great. Next one, is there a need to reply on a corporate PKI to identify parties?
Sorry, can you ask that question again?
I think that's
sure.
rely. So do you need to rely on corporate private keys and third parties, or can you roll your own?
Yep. So the Orion key management is based off of a custom sort of public private key system, using the similar sort of setup to what's used in the quorum networking, and so it's not using PKI for it. You need to be distributing the public keys and having that sort of out of band to the system itself.
Next one we had, in terms of deployment, is it DMZ company policy compliant, i.e. what are the network protocol to open?
Yep, so at the moment it runs, so the Orion communication runs over HTTP or HTTPS, and then the Pantheon communication runs over P2P.
So to clarify, on the Orion side, it's point to point, basically. So you need to open up to the people in your consortium.
Kyle just asked, is there a public place to follow updates with this roadmap / technical capabilities?
Yep, so our GitHub has a roadmap document available there, and I think more generally on our blog, as we have releases that have significant updates to the technical capabilities, that's a great way to keep on top of some of the things that are happening.
I think that should answer all the questions. I didn't, for the audience, some of the questions from earlier I didn't answer because they were answered in the presentation later on, so that's why they're not being addressed at this moment. But anyone is free to speak up or ask more questions in the chat. I think that's all we have queued up at this point.
And so just seeing in the chat some good comments about the DMZ. So getting good DMZ support is something that we're thinking about. It would be great to set a follow-up conversation. So if you send an email through to the pegasysinfo@consensus.net, it would be great to do a follow-up call around where you sort of see some of the issues and ways that we can make that work well.
Is Pantheon in any way dependent on a hardware security module?
No, not currently. And I guess dependent on it would not be able to support. It's in our roadmap.
Looks like Ken just asked one. So right now, if you need to create a US dollar token contract with shielded balances for each holder for a bank settlement network, how would you do it?
So for those sort of solutions, I'd be looking to use a zero knowledge solution. So using something like a Aztec, the Aztec protocol, or one of the other sort of zero knowledge solutions. So there's a blog post that's on its way from the PegaSys privacy team talking about how they went through getting Aztec working in a consortium network.
Any other questions? Oh, what does the block time your protocol have?
Yep, so I don't have the good answer to that. Hopefully, either someone on the call might be able to drop something into chat with some of the configuration options that we've got. We have, I guess, two different things that sort of help impact some of the block time. So we have a proof of work based option where you can configure the difficulty to be a very low difficulty and get a very produce blocks rapidly. And then within our IBFT to consensus mechanism, that also allows configuring the block time as well. And so with those, it can sort of really help with some of the block times, but I don't have the good answer to what the block time is. And thankfully, Madeline has come to the rescue, and you'll see there's a link in the docs to the IBFT block time configuration.
A follow-up question from Rajan is, does it support Raft as it has a better block time?
Yep, so we have not got support for Raft at this point in time. I guess just looking to get protocols that support good BFT and Byzantine fault tolerance properties.
Great. Last call. We have a couple minutes left. Any other questions? Amazing. Well, I think we're in the clear, Rob and Anthony. Thank you guys so much. And we did say that we will be sharing the Aztec demo, I think. Faisal was mentioning a couple of people are asking next week when it's out. Thanks so much. We're going to end the recording, and we'll be sending a follow-up email to everyone.
Great. Thank you so much, everyone.